Hello, everyone. Today I kind of want to test YouTube live streaming. This function actually this is for Sunday summer class because there's too many kids join the class. I'm not sure. Could you try that from your end? See if the YouTube live streaming is working.
On the top right, I could see live on YouTube.
Today I kind of want to test YouTube live streaming. Okay. Actually, did for Sunday. Good. Yeah, that's kind of a little bit, delay. That's normal because there's too many kids join class. I'm not sure. Could you try that from your end? See if the YouTube live streaming is working.
On the top right, I can see live on YouTube.
Today I kind of want to test the YouTube live streaming. Okay. Actually, it's for Sunday. Good. Thank you. That's very nice, right? Yeah, sometimes YouTube not working and sometimes Facebook not working. I don't know. There's also always some technical issue with Zoom. Yeah, all right. So let's get started. Are you ready? May I ask all of you to turn your camera on? Is okay? Thank you. So, I want to talk to my student, not a black screen, all right? That's the reason why. I want to see you want to see me, right? So just be careful. So if you turn your YouTube live streaming on, could you please just turn it off? Otherwise, I will hear some. Okay. All right. Thank you. Thank you. All right. Okay. Please turn all your, let me see. Ask to start video. Everybody, please start your video. Please, I appreciate that. Okay, don't be surprised. We already been together, I think more than a month, right? Let me see. I'm trying to bother you everybody, ask you to turn your video on. But I don't know, is where can I just like one button to get everybody's video on? I don't know. But it didn't show here. Okay. All right. Okay. Nice. Okay. Thank you very much. Okay. Let's get started. Now it is 7:02. All right. I'm not sure if you can see my screen. No? Yeah, okay. Share my screen now. Good. Now you should be able to see my screen, right? Okay. Let's look at homework. Oops, I have to put it out here. All right. Edit. All right. Here we are. Oh, wow. We have more than 300 submission. Thank you very much. Okay, I believe you definitely did a lot of homework. That's good. All right. See, I see there's more high bars. So for those people with a low bar here, could you please just, start doing more homework? Or you may just already done your homework, but you forgot to submit the survey form. Please do that, all right? Okay. Quickly see this. Last time I saw one student achieve 2,000. I remember it's here. It's almost yeah, 2,000. Oh wow, who's that? 2,889. Oh wow, good. Okay, hopefully next time I can see more. More of you have a score greater than 2,000. Or somebody probably can reach to 3,000. Yeah, that's very good. I think during summertime, we may have a Alcumus study group. So I hope all of you can join that. We will have a fixed time to study the Alcumus together. All right, so I have not got a detailed plan yet, but parents is volunteering to do that. Will lead the Alcumus study group. All right. Good, thank you. All right. All right, thank you very much. 310. Very nice. Okay. All right. Let me see. Oops. Let me pull out my pen. All right. So here, let me see. Where's my pen? Oh, here. All right. Yeah. Last time.
I'm doing YouTube live streaming too.
Hi. Could you mute yourself?
Live.
Could people all mute yourself? Yeah. Let me do that.
It's live.
People need to mute yourself. Oh. Standby, could you mute? I cannot mute from my end. I don't know why. Okay. All right. That's fine. Yeah. For this, for last class and this class, we are going to learn the linear equation with one variables and multiple variable. Last time we learned multiple variable expression, right? But now this time we are going to learn I think we learned equation as well, but now okay. This is last time, chapter 4. We learned the distribution and factoring, also the fraction. And then we learned the equation, right? With two variables, right? So for this time, let me see a little bit. I think this time we will learn the multiple variable equation. Chapter 4, we learn. Oh, okay. Could you please mute yourself, or you have to turn off your YouTube? live streaming. All right, please. That's just for testing. Okay, thank you. You know, here's the thing. We have one variable. We call one variable expression. If we have equal to 0, we call this one variable or linear equation. Then last time we learned something about two variable or multiple variable. It could be x, y plus z expression. And then we also learned some operation about the distribution, factoring, and then fraction, like x plus y as the denominator, right? And then we learn a little bit of the equation. For example, is equals 0 or something else, right? So, and then by reading this word, you can see that we can sometimes isolate one variable in an equation with multiple variables. For example, we isolate x.
Let's do this.
People, students,
Stop.
please,
Let's do this.
please mute yourself. Okay. All right. So we isolate x from this two variable equation. You definitely just move this one to the right side. You only leave the x on the left side if you want to isolate x. In the situation, if you want to isolate y here, you need to move x to the right side, right? So it becomes, for example, 2y equals 3 minus x. And then the next step is you want to remove this 2, right? So I'm sorry.
Isolate it.
Could you
Look at it
please
side
mute
by
yourself? Hi, could you please mute yourself? All right. If you have any question, you can raise your hand just by clicking the button, right? Okay, I can see you on my screen. All right, and then you can unmute, and then you can unmute, and then later on you can mute yourself. All right. So here you wanna remove this coefficient, right? You need to divide it by 2 on both sides, and then you will get y. So as I said, if you can quickly turn this 2 to the right side and becomes the reciprocal, it will be 3 minus x divided by 2, right? So for a variable or number, and then if you move from left side to right side, you change the sign from plus to minus or minus to plus. But if it's a times something, okay, 2 times y or y times 2, if you want to move this one to the right side, you just turn it into reciprocal, just like flipping it into the denominator. That's the simple and easy way. All right. Okay. So, okay, we can start the chapter 5 now, because we learned some multiple variable expression. We just put two, as I said, we put two, we put the two multiple where multi-variable expression together and put the equal sign here, and it becomes a multi-variable linear equation, right? So today I'm going to teach you some basic linear equation, two variable equation, and then similarly as the basic arithmetic operation substitution. Oh no, that's different one. So this is substitution. That's really similar. I think this is probably unique to the two variable or multiple variable, and then elimination. All right, and then for next class we are going to cover these three topics. So we are going to use 2 class sessions to finish this chapter 5. All right. So before we go to the the concept of so let's do some preview problem. Please write down this on your paper, and then just think about This is definitely something we're gonna learn from this class, and at the end of the class, you will feel it's easy to solve the problem. I can give you a little bit hint and just trigger you thinking about it. But here, suppose that x equals this. Here, y equals this. Looks like it's not 2 variables. It looks like it's a 3 variables or something. Or maybe generally we think x and y are variable, but the t will be a constant. T will be constant, but it really doesn't matter. You can consider t is a variable or a constant. That's fine. But here, what it's asking you is find x in terms of y. What this means, you have to think about. First, you have to know what problem is asking you to do, right? So basically, you kind of like express x with y or something y, okay? You kind of like isolate this language equals the isolating the x, or solve the x, or use y to represent x. This is what it means, okay? Then you think about, you have x equals this, you have y equals this. X and y have the same variable or fixed number, whatever, a t, right? It's unknown number. We can call it unknown. So have both unknown. What we can do, right? Just think about it. And then with this question, and then let's go to let's start this. So let's just think this is very simple example that this is two variable equation. On your left side there's x and y, right side is a constant. So generally, in a simple way, you kind of have this list, right? And you can just assume x equals 5 and you got y equals 1. You can have many way or many possibility to list a different number here. What about situation for x equals 11 here? And then what y is? But I think you definitely, everybody should know that. All right, you plug the x in, or we call it the substitute x equals 11 into this equation. You get 2 times 11 minus 3y equals 7. And then you can solve the problem, right? Becomes a one variable equation of y. You know how to solve y, right? Because we learned that. And then you can get y equals 5. Now you have 5 to fill in here, right? So of course there's many other possibilities. So that's the reason why we call the x and y is kind of a placeholder. It could be any number, and then it is a variable. So we call this a pair of solution, ordered pair, and then we use a parenthesis and with comma in between here to represent this. Oh, I need to give you a few seconds before I move forward. Any question? This is really some basic concept of two variable linear equation. And is this. But generally, like I mentioned before, that for two, if you have two variable equation, you have two variable equation, like showing here, you will have multiple pair of ordered pair, or multiple answer, right? It could be multiple answer. not single answer. What about situation? Let me give you an example. If you have another two variable equation, for example, is x plus y equals 1. And then you will also have a table like this. For example, x equals 1, y equals 0, 2, minus 1, right? So if I'm asking you, if you want to have x and y both satisfy two equation, we call system of equation. In that situation, you will only have one solution. Okay, I'm going to tell you more. And this is just give you a little bit heads up. All right. Now, consider the following two equations. You can see that this is for the both equation is kind of in a standard form. There will be x, y, and here will be the constant. X, y, and then constant. Right? So it's asking you to use a trial and arrow to find a pair that is a solution to both equation. This is kind of like a similar, to the example I just show you in the previous slide. It's kind of because this is like a single digit, and then using your mental math skill, you definitely can easily figure out what x and y could be for first equation, right? So x and y could be, x could be 2, 3, 4, 5, and so on. And y will be like this, right? Just like a table I showed you, that could be a long list. What about for the second one? The second equation, you will still got the same thing, right? So this is for the first. So this will be for the second one. All right. So you have x equals 3, 4, 5, maybe 6, 7, 8, 9, 10. And you got the corresponding y, 1, 5, 5. Sorry, this is 9 over 5. Okay, this is 7 over 5, right? So, and then because the problem is asking you that find a pair, okay, is only one pair, as I said. For two variable equation, you need to have two equation, and then you will have one pair, right? Keep this in mind. This is general rule. Let me stop here a little bit. Let me ask you another question. Just follow same logic. That's the reason why I'm always talking about the logic. What about if you have three variable? Four. Here's 4. Okay. Do you think you can get one solution or two solution or three solution for x, y, and z? Or how many pair? Anybody? Any? I'm talking about three equation, which are three variable. Anybody can tell me if you can get a single pair of x, y. This we call this is a set. Or okay, x, y, z. You can get one or multiple. Have a guess. Don't worry. So generally, if you have three variable, okay, you need to have three. You need to have three equation, okay. Keep in mind, you will have three equation, then you will get a single answer, right? Otherwise, you still have multiple answer. It depends. It depends. And also sometimes the equation, we call this is a system of equation. The equation may not have a valid answer. Not always. Keep this in mind. Later I will give you example. So here let's continue. Go back to this two equation. Okay. Then you realize that for the first equation we got this list. Second equation we also got the list. As I said, they're supposed to have a common solution, which is 3 and 1. Okay, you realize all the others supposedly not the same. Only one pair of solution. Okay, that means 3 and 1 is a solution to both equations. Okay, I'm not sure if any of you have has any learned something advanced about the graphing the linear equation, and then that can help you to explain why you will have one solution. Anybody any idea? Do you know? Yeah, but later I definitely will teach you. I can give you a heads up as well, just help you understand. You just to keep this in mind. You do not need to fully understand why, and later on you definitely will learn that. So we know this is a plane, right? So we have x and we have y. For a line, we generally can we call this linear equation, right? We can have x plus 3y equals 6. We can plot a line here. For another one, for the second equation, we can plot another one like this. If I give you a little bit heads up here, and then you will definitely easily to understand later. So I believe everybody know that for two lines, either they are parallel or how many crossing points do they have for two lines? If they are not parallel, how many crossing points do they have? One, okay? That's reason one. Two lines, either they are parallel or they can cross out and with 1 point. This is really like a really common sense, right? I think you all know that, okay? Here, let's read the words a little bit. Let me clean up here a little bit. So, a group of equations for which we seek value that satisfy all of equations at the same time is called a system of equations. I mentioned that because one solution will satisfy both equations. We call it a system of equations. Okay. So just example that this one solution can satisfy both equation. And you can think about because both of them can represent a line and there's only one point, okay, we call the intersect point as well, right? Okay, so it will be one solution. All right, so remember that today we are going to use two ways to solve this system equation. One way is substitution. Why we do substitution to do that? Think about it. If you want to solve this system equation, right? You want to find what is x and what is y, because you keep having two variables in both equation. this will really bother you, right? If, for example, if the first equation is x plus 1 equals 4, this is one variable, you can easily to solve this problem because this is last time you learned, right? One variable equation, that's easy. You just move this one to the right side, become to -1, and then x equals 3. That's easy. Do you think this situation will be easy as well? I can tell you yes. But why? How you make that easy? The way is to remove one variable and then you turn two variable equation to one variable equation. Then all the problem are solved, right? So then how do you eliminate one variable? Which variable are you going to eliminate first? This is gonna be a question. Then you think about, as I said, to solve system equation is easy, but sometimes with tricks. Okay, you have to look at this, all the coefficient. I'm saying all the coefficient because for variable they are same, but the coefficient are different. The way to find out the easiest way to do it, you have to be careful about the coefficient, and then which will direct your way to solve this problem. Okay, so here I put this highlight words here. Eliminating one variable, right? This is the key point. I will mention that again, and again. Okay, for example here, for the first equation, you can move this 3y, another variable to the right side, it turned to -3y, right? Now, you have x equals 4 minus 3y. And then you just plug this x into the second equation, or we call the substitution. Okay, substitution or replacement. Oh, I would just like to use the word plug in. Okay, if you plug in the x here, and then you replace the x with y, with the expression of y. So basically this is x. You just replace it. And now for this second equation, you totally remove the x. You only have y there, right? So now, as I said, you turn the two variable equation, or turn a system of equation into one variable equation of y. Now, you know how to solve this problem, right? You have to do the distribution as you learned last time. Distribution, okay, and then you combine the similar term together, and then you will get here, like for example, here you have 11y minus, you move this one to the right side, becomes +8, you will get minus 22, and now you get y equals -2, right? Now, by doing this, you got y equals 2. What is x? Obviously, you can plug this y back in to any of these two equations. But which one you want to replace y equals -2 into? Of course, you're going to choose the first one. Why? Could anyone tell me why you want to choose the first one to plug y -2 in the equation, but not the second one?
It's shorter.
Yeah, it's a lot easier.
Yes, a lot easier. But first one is a larger number. Yeah. So then, as I said, but if you do the second one, that's okay. But it just makes your computation a little bit more challenge. But this is a simple example. But sometimes two equations, is very are very different. So you definitely will choose a simple one to plug back in, because this sometimes I will call this is a combined. This is a combined equation from both equation. okay? And then once you solve this problem, you going back, okay? It's kind of like a cycle. You have two equations, and then you combine them together into one equation. You solve the problem y equals -2, and then you going back, plug back in, and then you will get x and y. This is okay. Clear? You have to learn this strategy first, all right, before you practice. Okay. So as I said, substitute this one for x, and then you will get xy. Okay, 10 minus 2. Yeah, just as I said at the beginning, you just kind of like watch a just listen and then listen a story, and then you know the idea, the strategy, how to do that, and then I will give you time to practice. All right, and then here's a summary from the book. It's just saying that one common approach, okay, common approach to solve system equation is to solve for one variable in one equation in terms of the other variables, okay? Just like you isolate x and then you got y, and then substitute the resulting expression into the remaining system in remaining equations in system. Yeah. Again, just repeat. Isolate x, right? And then substitute in to the second equation, and then you get what is y. You got the solution for one variable, and then you plug back in to get another one. Okay. So here this is a I think now is the time for you to practice. Give you 2 minutes. Please follow the way I just taught you. Find an easy one. I think which one is easy? The second one is easy. And you can quickly find out or isolate y, okay? Isolate y from the second equation. And then you substitute y into the first equation. And then you will quickly get x, what x is. Once you get x, you plug back in to the second equation because second equation is simpler than the first one. And then you will get y. Anyone got the answer? You can raise your hand. I think just like I said, it is not difficult at all, right? It's just add additional variable. You just remove one variable and turn it into one variable linear equation. And then you got the answer, right? So looks like, you know, this is nothing new. It's just change a format, add additional variable. Let me know if any of you have solved the problem. You finished? Feng Yan?
I'm done.
You done? Okay. All right. Good. Let's wait for 10 seconds.
Yes, sir.
All right. Yeah. Let me know what's your strategy. Yeah. What's your strategy first?
Me?
Yeah.
Oh,
Feng,
so I just made y for the second equation, y equals 5x minus 9, and then I just plugged it in, which is for the first one because it's a bit easier. So it's 3x minus 2 times parentheses 5x minus 9 equals 7. And then 3x minus 10x plus 18 equals 7. And then negative 7 equals 11. And then 11, and then it's 11 over 7.
okay. Yeah. And yeah. And continue. What is y? Because it's asking you, the solution has to a pair of number x and y, right? You need to continue.
Oh, wait,
That's okay. That's okay. Okay, nice work. All right. I hope all of you at least do the same thing. Yeah, please mute yourself. Okay. Right. So yeah, as I said, first, if you see two equations, you definitely can easily identify which equation is easier or simpler, because especially for this situation, if especially you see the coefficient 1 will definitely help you to solve the problem, either x or y. If you see this one is -1 coefficient, which is it is a good sign for you to start with here. Okay, keep this in mind again. Coefficient 1, okay, for example here, or -1, will be a good sign for you to start from here, right? So now you can isolate y easily, right? You got this. And then you substitute this y into the first equation, and then you will get this. And then you use distribution property, okay, and then you will get this. You combine them together, we got this, and then eventually this one becomes 7. And then you can isolate x or solve the x. You will get 11 over 7. All right. Now it's not done yet, because you have to remember to solve y. As I said, you got here, you got x is, you have to plug back in to the easy equation, this one. You plug in back in x here, right? So, and then you get y equals 5x minus y, and then you got y equals -8 over 7. All right, it's simple, right? Yeah, and it's just like this logic, as I draw here is a circle. Two equation, you got combined one by plugging in one into another variable, and then you solve the solution for one variable, and then you plug back in the easy one, okay, the easiest equation. All right, then you will get x and y like this. Let's do next one. Solve the following system equation. Yeah. And then meanwhile, so we can take a brief break, and then we can come back 7:50. All right. If you wanna continue to work on this, that's okay. All right. Let's get back. I'm not sure if any of you already have some idea solve this problem.
Oh, I solved it.
I'm sorry. Yeah, please unmute yourself. Yeah.
Well, I solved it.
Oh, good.
Great time.
Yeah. Tell me, what's your idea to solve this problem?
Oh, so I made the second I mean the first one into to make like make it have no fractions. I just multiplied by 2, so it was 6r plus s equals 33. So and then I just plug it in for the second equation, and then it is a negative 5r over 2 minus 2 times 2 parentheses 33 minus 6r equals negative 37 over 2, and then I just multiplied it. So like the first one, I made it into negative 2.5r, and then minus 66 plus 12r equals negative and 18 and a half, and then it was negative 2.5r plus 12r, and then I put the numbers without the variables on one side, which is negative 18 and a half plus 66. And on the
Okay.
R side, it's 9.5R, and the other side is 47.5, and it's R equals 5. And then I just plugged it in for the first one, and then got S is 3.
Great, wonderful. Thank you very much. Yeah, I appreciate that. Your strategy 100% correct, and then your final answer is right as well. Yeah. Anybody else? You have any questions? But I definitely will give you a little bit explanation here. Yeah, exactly like what you said. Here, like I said, if you see some denominator, here is a fraction here, you always want to remove them. But not just the first one, for second one, you can also do the same thing, okay? This is definitely sometimes make it simpler, right? And then also to avoid some mistakes in your calculation. If you want to remove this 2 in the denominator, you just simply times 2 on both sides, and this times 2 on both sides, right? And then apparently you see the first one is simpler than second one, but basically they look similar, but the first one still simpler than the second one. And then if you multiply by 2 on both sides, you will simplify the two equation like this way, right? So now it looks much better, right? Very simpler, right? And now you have R, S, S, right? You have two constant here. Like I said, when you have a system equation in different format, you try to convert into this standard format with two variables here line up, and then you have constant on your right side, okay? Then you solve the first equation to isolate S. You get S equals this, right? And then you plug in here. So this one give you this, and then you plug back in here, and then you get combined equation, from both this equation, right? You got R equals 5, and then you plug the 5 back in to the single one to the first one, right? It's kind of like a cycle. You plug back in, and you got this final answer, right? So I still need people to mute, right? Okay. See, this is a summary from book. You can get rid of fraction in equation by multiplying equation by the least common denominator of the fractions in the equation. Yeah, but this one easy, right? The least common denominator just 2. 2. Yeah, it's very easy. But this is tells you a trick, right? If you see a different type of denominators, sometimes may contain the variable, and probably later on I'm going to give you some example. All right, this B. Okay. Let me see. We see today. Yeah, I think we probably have time. I would like to give you 2 minutes to think about. You may or may not to finish. That's fine. I mean, at least you have some idea, and then you can do it in the middle of it. That's fine. I mean, like I said, problem solving skill is more important, right? While you're learning. So to find an accurate answer, it definitely need you to do a lot of homework, a lot of practice at home. Okay, you can start. Don't wait. You can start. Just while you thinking, I'm just want give you a little bit hints. If you don't mind, I just keep talking and then you calculating. Here's the decimal place. What you can do? Decimal places looks like fraction, right? How do you remove that? I think in my class, I never talk about that, but you definitely should have some idea to do that. Like I said, you have to convert it into standard form of the system equation by rearrange the variable to your left side. Keep the constant term on your right side. Okay, I think probably many of you already have some idea, but probably will not have enough time for you to completely finish this problem. But like I said, you have to convert this system equation into standard form to help you, because otherwise you have x and y on both sides, and then on also different side on the for the second equation, right? What you can do is you just rearrange this. You get x, y, and y here, and then you get constant number on the right side, right? Yeah, everybody please listen to me first, okay? If you want to complete that, you can do that later, but not at this moment. You get, because you are learning, you will have a lot of time to practice at home. Here's the thing, like I said, if you think this decimal places really bothers you, this way probably different from the book. I'm going to write here. You can definitely move this decimal place, this is point to 2. Okay, you like basically you times 100, you can get 30x plus 100, right? 120y equals 93. Can you do that? Right? Because you times 100 on both sides, because you know that 0.3 equals 3/10, and also equals 30 over 100, right? You all know that. You learned the decimal, right? Okay. So for this one, if you want to remove these decimal places, and then you simply times 10, you get a 20x minus 8y equals 18. All right. So now you have very simple system of equation, right? You can solve this problem, right? So this similar as perfect example. However, the book, keep using decimal numbers here, and basically what the book does was I think a get variable. Okay. Let me see. Looks like it got yeah. I don't know. Maybe I didn't capture what is really get here, and then it's eventually like this. But let's look at this. Okay, use it this way. So for example, you have 30, you have 20 here. What do you want to do? Here is okay. I know what he's doing. The book just using isolating, same one as well. Isolating, and then is doing this divided by 2 for the second equation, right? Divided by 2, and then it's divided by 2, and then move to the right side, it becomes a 0.4y. And this one divided by 2, 0.9, okay? So basically, the second equation, the x was isolated, right? And then substituting this one into the first equation of this, and then it becomes, because this is x, this is x equals, right? Okay, it's a substitute in, and then it get y equals this, and then plug back in of y equals 0.5, and then into the I think this equation, plug back in here this equation, and then got 1.1, and then it will got this pair. What about this way? Alternative way. What do you think you can do? But that's still same thing, right? You can do this 8y, right? You can easily to get 20x minus 18 equals 8y. You want to remove this 8, you simply get 8 here, and then you cross out this here. And then you got y's, right? But of course you can just cancel 2 here, and then it equals 10x. But actually we kind of like this way a little bit simple, we complicate it. But I can tell you that this way, because is y equals let me continue, 10x minus 9 and then 4, right? So now it looks like sorry, you complicated one, and then here it still has the denominator. So probably you realize this is not probably not the right way to do this, right? And then you think about, of course, I'm going to teach you another approach instead of this substitution way, okay? Keep this in mind. Not always you use one way to solve the problem, but this situation looks like it's not simple at all. And then I'm going to teach you next one. It's called the elimination. Elimination. Why we call elimination? Because as I said, for the previously substitution is just eliminate one variable. For this elimination, basically is using the addition or subtraction equation, okay? Using the way of subtraction or addition two equation together to eliminate one variable. So the goal is the same. The goal is the same, okay? So let me give you an example, and then we can go back to previous example I show you and why you think about there's alternative way. So as I said, this will be your second way to solve the problem. Okay. For example, here, this is a system equation, right? You have this. Interestingly, look like this is a +3. This is a -3. Of course, you can use the previous way you just learned. You can find a, you can isolate y. For example, first one, you can isolate x, right? You can get x equals -3y minus 11 divided by 2. And then you plug in this x here to here, right? And then you can find y is. This is quite similar as the example I just showed you in the previous slides, right? However, there is an easier way because you have solution equation 1, equation 2. As I mentioned here, you have +3, you have -3. You can add the both side of this equation together. Oh, okay, left side, both of left side together, and then both the right side together. It's just like a regular mathematical operation, right? And then plus 3x and minus 3x, it becomes 0. And then you have 2x plus 5x, you have 7x on your left side, on the left side of the equation. On the right side of the equation, of course, you know, -11 plus 67 equals 56, right? Okay, now this is really an alternative way to eliminate unvariable. Why you can eliminate a variable? Because here you have +3 and -3, and the addition of these two equals 0. Okay, keep this in mind. This is the point. Okay, plus and minus. Let me ask you this. What about situation? Just for example, here's a +3y. Here's a +3y. What you can do? How do you eliminate 3y quickly? Yes, please, Feng Yan. You need to unmute. Unmute, please.
There are two 3y's, so and like the bottom one is a negative 3y, so it's 3y minus 3y 0.
Yes, just use subtraction. Because here on your left side you use addition, but here for this situation you can use subtraction, right? Subtraction. Yes, as I said. Thank you. Now, like I said, here we have x and y and a pair. It's very easy, right? Okay, so solve system equation of this. Okay, what you can do? I can give you 2 minutes to practice. A little bit challenge, right? Because there is no really like a +7 and -7y. You can just directly add them together or subtract them. What you can do? But you may realize here is 2, here is 4. Can you times 2 on both sides? Right? And then you turn this one into 4x plus 6y equals -10. Right? And then what you can do next? That will be very easy, right? Like just Feng just said, for this situation, you have the same thing. 4x, you can just simply do subtraction. Yeah. So the book multiply -2 because it want to turn it into minus and then because here is a minus, that's fine. And then becomes a -4x and then -6y plus 10. That's okay. But now it's turned to the addition of the equation, right? So becomes this equation and this equation, they add together, right? They add together because this one 0, and this one add together will be minus 13y equals 23. So exactly you got this. All right. Now you can simply isolate y, find the solution is minus 23 over 13. And then you plug back in, you will choose either the second one or the top one. Actually, they're not too much difference, either one. And then you will get x. Okay, it's kind of like a several step, you know. It's a cycle. It's a cycle, like I said. Okay. Then let me read this words from the book. Even you cannot immediately eliminate the variable from a system equations, you might be able to multiply one of the equation by a constant. For this example, constant minus 2 was applied, so that you can easily eliminate a variable from resulting equation y. So the point is, like I said, you want to eliminate a variable. How do you eliminate a variable? You have to make the coefficient of the variable in every equation identical. Because here's a 4x, here 2x, you have to make them identical or a what they call opposite or negation of the 4x. Because negation of 4x it will be minus 4x, right? And then you add them together. Okay, then you can eliminate it. Otherwise, you cannot eliminate this x. Okay. I think this is definitely exactly the example I just want to show you that the alternative way, you turn that into, okay, if you have identical coefficient for a variable, you can use subtraction. You subtract this one, there will be 0. And then because this is a minus going to here and becomes a minus, and then this will be minus 6y, okay? And then it becomes minus 2y. And then here you will get minus 26, right? Okay. Give you a little bit time to think about it. The point is to eliminate the variable. How do you eliminate variable? You can either use addition or subtraction. Okay. Solve the following system equation. You can use either substitution or elimination. Remember, we talk about two topics today, two ways to solve this system equation. One is substitution. You isolate x into the format of y plus something, and then you plug in x. You got a combined equation, right? Second one is you do the elimination. You have to find the identical coefficient of one variable in both equations. Then you can eliminate it by applying addition or subtraction. Okay. Then you choose method you find most convenient. So basically the question asking you to try both way, and then you will find which way is better. So you want to try? Yeah. Keep in mind here 2y, okay? 2y term. What you can do? Combine them. And write as the standard form. All right, I think probably you definitely will have some strategy already in your mind. You're probably in the middle of the the calculation. That's fine. Please look at your screen. Please look at your screen, and I'm just going to discuss with you about the a little bit details. So two ways, right? Looks like you have to do something here. Because this is minus 2y, you definitely want to move this to here, and it becomes 2y plus 2y, and then you combine with that, right? And then you keep the x, and then you move this one to the right side, becomes to minus 22. So we call this organizing or rearrangement, right? So like I said, for the second one, second equation, you got this. And now you get a system of equation. What you do is you multiplying here. What are you gonna do multiplying? Because you're gonna find your goal is to find to get a same coefficient. For example, here is I believe the book choose the y, okay? Same coefficient for y. So between -2 and 3, what is the common multiple? Common multiple, right? So that will be easy, right? For you to figure out. You times 3, and then here it becomes -6. If you times 2 on the second one, it becomes +6. -6 plus 6, and then that becomes 0. That's the reason why you multiply a factor on both sides for first equation, 3 on both sides, and then 2 on both sides for the second equation. Now, and then you add them together. Oh, here we go. You add them together, right? So you get -6 plus 6, and then it's 0. And here you got 3 minus 3x equals -8. You get x equals 8/3. I hope some of you already probably here. You got x. So just you need to continue to figure out y. And then what you can do is plug back in. Which one? I think the first one. I will choose the first one. The first one small number, right? And then you will get y. Clear? Yeah. All right. Give you a few seconds to think about it before I move forward. See, it is easy, right? Very simple. Just remove one variable. And then the point is depends on which one you are going to choose. Which variable are you going to choose to start with? X or Y? You have to look at the coefficient and use your strategy, right? The strategy is this either substitution or elimination. But here, basically, we use the elimination. We haven't tried the substitution. But if you want to do substitution as here, which one are you going to choose if you want to do substitution? Just quickly tell me, what's your strategy if you apply substitution? Which equation are you going to use? Or which variable are you going to isolate? You choose the simple one. Which one?
I would isolate y in the first equation.
Yes, exactly. You look at all the coefficient. This is the smallest coefficient too. And then you choose this one as the starting point. This is the trick part, right? Find the starting point. This is the smallest number. Thank you, Leo. All right. And then you isolate y, and then you plug into the second equation. You can solve y. Once you got y equals something, you plug back into the first equation here. Right? Okay. I think I repeated this one many times. You definitely will get it. The summary, we have to multiply both equations. Previous example, we only multiply one equation, but now we multiply both equations. Why? Because if you only multiply one equation, you cannot eliminate because they do not have common coefficient if you only multiply one. Only for this situation because the common multiples is least common multiples is 6. You have to multiply 3 to the first, 2 to the second. All right, another one. This one. I think I will. You don't need to calculate. You just have a quick think. Give you 10 seconds to think about what's the best way to solve this problem. Just a mental map. Mental math. You do not need to write down anything. What are you gonna do? Which strategy? Remember we have two strategies. One is substitution. Second one elimination. Which one?
I would use substitution.
Correct. Why?
Because in the first equation, it's 2t minus r equals 1, and then it's going to be really easy to substitute t out, like to solve for t, and therefore you can put it into the second equation.
Yeah, that's kind of correct. But do you think the r?
Oh
the
no, r.
Yeah, the coefficient, the coefficient of r is the smallest and the easiest one.
Yeah,
You
that's
move
what
this
I.
one to the right side, yeah, it becomes plus r, and then move this one to here, it's minus 1. Yeah,
Yeah,
correct.
very easy.
Yeah,
Mhm.
very easy, right? Okay. Otherwise, if you want to do the second approach, elimination, you see, it's hard. Like if you do this and this, you have to times this 5 and you times this 2, right? And it's become 10 and here's 10. It's kind of where you know you multiply two different things and then you do the addition or subtraction. Correct. Thank you very much. Thank you. Yeah, let me skip this. I think the way of that, you know, the book using different way. Okay, but anyway, I think the using substitution way probably the best. All right. So let's look at this. For what value of constant c does the system equation below have no solution? Huh? This is another no solution problem. This is very tricky. Remember, you may or may not know sometimes, you know, we see this type of problem, we always think about some special situation. For example, if we say, at what situation, equals 4, okay? 1 over x equals 4. At what situation this equation does not have solution?
If x equals 0.
Yeah, and then x equals 0, right? So it's kind of like similar to this, but not exactly same as this because the expression is not in denominator, right? But then you think about, what's the solution? Is you have to find out something in mathematic rule. It will it will now be valid. What you can do? What you can do? Think about it. Right? Looks like you will not have any idea. It's hard. But it's hard doesn't mean it's hard you do not have any idea now. It doesn't mean you will not have any idea when you start with something. If you start with something in the middle of your calculation, you may have some idea, right? Okay. Rather than no idea and giving up, right? You just try something. At least you know this is standard form of system equation, but what can you just convert this one into a standard form? Okay, and then what you can do is you doing that standard from x, y, you just line up everything, right? And then you think about, okay, let's try the elimination approach, because you have 3, you have 6, or you can choose this, that's fine. You have C or Y, right? That's fine. I mean, rather than, because here is C, this is an unknown number, but you probably try this, right? What you can do this, you times 2 on both sides. But the book said, in -2, that's okay. We can use -2. That's okay, it doesn't matter. So after you multiply -2, you get this, right? And then and then you just multiply them together. You got 0. You got the 10y minus cy, and then you got you got the 13.9, right? And then apparently you can see that you can factor out y, 10 minus c equals 13.9. Correct? You can do that, right? Okay. And then, okay, now you have this. So for what situation do you think y will not have solution? What situation y will not have solution? And what situation c equals? And y will not have c. If c is a number, you can always write as y equals 13.9 divided by 10c, right? Now, you have some idea what situation y will not have solution. Look at this.
C equals 10.
Yes. If c equals 10, y definitely will have no solution at all, right? So now you know definitely c equals 10 will be the final answer. All right, because if you have c equals 10, you definitely remove the y, it becomes 0 equals 13.9, right? Because here is a 0, and then you remove the y. There's no y is gone. You got 0 equals 13.9. Of course, it's not right. All right, here we go. So c is any value besides 10. Okay. All right, let's revisit the problem at the beginning. Suppose that now you look at it very easy, right? X and Y, find X in terms of Y. So you temporarily forget what T is, or what you can do. You just like, what do you think? X equals something about Y. What you can do? But here's the T bother you. What you can do? Because this is special situation. It doesn't ask you what exactly X equals something, Y equals something, or is it something I already told you that you have 3 variables. If you consider T is a variable because T is an unknown number, you can sometimes think about it is an unknown number, a variable, right? So you have X, Y, and T, 3 variables. You have 2 equations. You definitely cannot find a single answer or single one answer because 3 variable. The number of variable greater than the number of equation. Okay, for this situation, in general case, you will not get one answer. Okay, keep this in mind. So here, let's look at the solution 1. If we use elimination. If we use elimination, right, what we can do is we multiply this second equation by 2. Why? Because here is a 2t, here's a 40 or minus 40, right? So then you will get this solution, this equation, and then you get adding this to, oh yeah, eliminate t, okay? Then because here is minus 40, this is a 40, right? So by adding these two equations together, but I know the format is not great, and then you eliminate t right away. So basically the goal is to eliminate t by multiplying 2, because it's too messy here, sorry about that. Let me clear up a little bit, right? So now it's good. You have 2t, you have minus 4t. The things here, you want to find this relationship or correlation between x and y. You want to eliminate t. Here you have minus 4t, 2t. You times this 2, it becomes a 4t, right? And then you add them together, you will eliminate t. After you eliminate t, you can get this right away, right? And then the problem is asking you, find x in terms of y. As I said at the beginning, this it can be interpreted as isolating, right? Isolating x, right? Or isolating x. So what next step is you isolating x, and then you got this. That will be the final answer. Another one is another solution, another approach. Another approach to doing this, we use the substitution. Like I said, you pick up the simple one, the simple coefficient, which is the second one. This equation. You can isolate t. And then you plug this t back into the first equation here. Right here. This t. And then you will get this. Looks like a little bit complicated, but you can cancel it easily. Right? It becomes this and then this. You will get the same answer from 2 different ways. All right. Okay. Give you a few seconds to think about it. All right. So it's kind of like it's just one. There's a additional t. It kind of bother us a little bit, confuse us. But then that's okay. That's okay. So you just follow the exactly rule for elimination. You eliminate t. Now you eliminate t. For substitution, you also substitute t. Right? You isolate t first, and you substitute into another equation. All right. Okay. All right. Review. Also, for this class, we learn two ways to solve the two variable linear equation. But like I said, if you see three variable linear equation, you definitely will follow similar rule. I think the key point or the logic is to decrease the variable step by step. For example, if you have 5 variable system of equation, including 5 equations in the system, what you can do? You have to find a way to eliminate the variable one by one. So you turn it into 4 variable system equation, then you simplify to 3 variable, and then 2 variable, and then 1 variable linear equation. And then you using 1 variable linear equation, you will find the final answer. And then using the answer you find, you plug back in, you will find the answer for other variable. Clear? I do not have an exactly example here, but I'm just telling you this logic. Step by step to eliminate variable to finally a one variable linear equation. Then you will find one answer. Then you plug back in. Okay, here we go. I know here's a lot of words and I already talked about it. Substitution and the elimination, and then the system of equation could be multiple variable, not just one, not two variable or three variable. It could be n variable. Okay. So, yeah, I think I already covered all of them, and then here I wanna emphasize a little bit that there are three possibilities for the number of solution of system that consists of a pair of two variable linear equation. Like I said, in general case, for example, two variable equation, you will get two solution. Three variable, sorry, two variable, you need two equation to get one solution, all right? Three variable, you need the three equation in the system. You still got one solution, all right? Okay, so however, in some cases, there's no solution. Just like one example I show you. Sometimes the denominator equals 0, definitely no solution, right? And then think about, and maybe also some other cases, you know, probably in the future, I'm going to give you an example, no solution, because you couldn't find a really reasonable solution that got no solution. Or in most of case, you know, we got one solution, as I said. If you have n variable, you need n equation, you still got one solution generally. So one solution is really common one, all right? So infinitely many solution. This is kind of, I'm going to tell you more about that. Just like, even though you have two equation like x plus y equals 1, you have another equation 2x plus 2y equals 2. Apparently, they looks like two equation, but however, they are actually same. Go here, 2, 2, 2. It's kind of like you times 2 on both sides of this, you got the same one. For this situation, it is one equation. So for this situation, you will have infinitely many solutions. X could be 1, y could be 0, x could be 2, y could be -1. You can have many solutions. This is the situation. Okay, 3 situations or 3 possibilities. Okay. All right. So this is our homework. Day 1 for 5 problems. Day 2, you have 4 problems. Day 3, okay, you have a little bit more. But don't worry about it. If you for day 2, you already finished early the homework, you can just start working on day 3. I really give you some flexibility. You can finish the day 3 homework ahead, all right? About day 4, AOPS, Alchemist. So, okay. And then always remember to fill out this daily survey form. All right, any questions? No? Clear? Okay, great, wonderful. Thank you. Thank you very much. Okay, everybody have a good night. Okay, hope to see you next time. Bye-bye.
Bye-bye.
Thank
Thank
you.
you.
You're welcome.
Bye.